Today I want to get started with the keyboard. So I already kind of got started with the software, so I've got a little AVR program that I could try. However, I need to figure out a way to connect this keyboard. I do not have the matching keyboard connector like this one here. I could desolder this one, but then again, I do not want to take this board apart just yet. Maybe I will need it for some reference signals. So I'm going to try to leave this alive for now. Plus, I don't know whether I can get this desoldered without breaking it. So I need to find some way to connect to this. I definitely cannot solder to it. It'll melt away the flat flags. I've tried things like that in the past and it just never works out. So it's a normal 0.1 inch pin header. So I can try maybe making something up with pin headers. I'm not sure yet. I found an easy way to do it, just using one of these old IE, so 40 pin headers. So we can just do it like this. This will simply contact one of the rows there, and then we can break it out on breadboard to wherever we need. The contact's kind of flaky, so just by putting in some paper behind it, we can make it a good connection, or a decent connection at the very least. So that's going to be enough for prototyping. And in the end then, for the final version, I'm going to desolder the original connector. I'm going to try and hope that it doesn't melt. And yeah, that's how I'm going to build the setup for now. Here's a little bonus clip, one of my really old designs, which is just a 3x3x3 LED cube, very cheaply made. I even screwed up the multiplexing matrix, and I don't know whether it comes out on camera. Yeah, it does. You can see, depending on the LED pattern, the middle one might get dimmer or something because I screwed up the electronics somehow. I don't know, I did this years ago, but right now I need it because it has an 80 mega 8 on it, and I noticed that I ran out of them. I have one left, but I need two for the design. Probably because I need way too many IOs for just a single one, and even an 80 mega 32 will not be enough. It'll be short by like 4 pins, I think. So yeah, one of my old designs has to go, and in this case, probably this LED cube will lose its driving IC. I should have a code somewhere so I can restore it if I need to eventually. Just now I completed the hardware setup for the keyboard. As you can see, here's the solution I have with regarding how to connect the keyboard. It's just the flat flags run into a simple pin header and then connected directly to the AVR here. And the AVR is connected via UART to the computer. The UART interface is the same that will later be used between the two AVRs on the IO controller, so not writing redundant code here. Yeah, so right now the code is simply set up to, each time I press or release a key, send over the UART command, which I'm going to show you in a second. Here's the AVR firmware. Very simple code, just multiplexing the matrix, running that in a loop, and each time we get a key event, we send it out over UART. Just for testing right now, you see I'm not even checking whether the UART is ready, so yeah, just very simple debugging code, but it's a proof of concept. Yeah, it scans the matrix, and then depending on this map, on these two maps here, it translates it into a key code, which is then sent over UART. I have not configured anything reasonable onto this yet, but whenever I press a key now, it'll send it over UART, which is displayed by the simple test program, which displays the key code that was received, whether it was a down or a key up event. And then it also, according to this matrix here, translates it into a Linux key code. So you can see I pushed a couple of random keys on the keyboard here. This is like from normal letter rows, but you can see like they're showing up as special characters, or they're showing up as left alt here. So I need to assign them properly, but this shows that it essentially works. I can just show you. I can press a couple keys now. So yeah, this looks pretty promising. That was a lot easier than I expected. After fixing one stupid bug, me simply forgetting to put the 8th column into these maps, now all keys work. Before, some keys simply reported 0, because of course if I don't set them here, the matrix will be pre-initialized with zeros. So yeah, now even the keys on the last scan will work. Just to show you how I did the initial analysis, I took a photo of the keyboard matrix and then just in GIMP traced out the tracks. Looks like a lot of work, isn't that much. It's kind of a pain. I tried to get the contrast right so I can simply click and fill, but that didn't work out. And before I set up properly with my camera and everything to get a good contrast shot, I just decided to do it by hand mostly. Yeah, and that's how I traced out the matrix, and that way I know which pin connects to which key. Then also to make sure that I'm not going to short anything out or something stupid like this, I went ahead and created this document here, which simply shows me again the mapping of the colors or the pins. In this case, like this is one port on the AVR and this is like split over 2 ports on the AVR. That way I can easily map them. But I suppose in the end I will probably just go ahead, look at these outputs. So push a key, write down the numbers, see which key I pushed, and then correct the number and do it that way. I think that's the easiest way to do it all. And that's probably how I'm going to do it. Yeah. Bit of a manual task, but it's all right. Also, what I didn't really explain previously, there's the FN key map, because there's a lot of keys that are missing from this keyboard, like the tilde or the F keys. And in order to get those keys, I will repurpose one of the, I think it's a delete word key on the original keyboard. Okay, it's not on the picture here, but this del word key, I'm going to replace that and make it function as an FN key. And that's simply done here in the process key event as well. If we get the key code for the function key, then I'm going to set the FN state to active. FN state simply here is the first parameter to switch the key code translation matrix, so it selects which of the matrices to use. Yeah, and that means I can create an entirely second key map for the FN key, where I can remap every key how I want. I could even like define that if we press this key, we get a different keyboard layout. It doesn't make sense, but I could. The only thing that needs to be consistent between these two key maps then is the position of the FN key. Otherwise, it will not deregister when we release the FN key. So after some more troubleshooting and some more stupid errors that I made, it works properly now. One mistake I made was I initialized the matrix last state vector with the wrong values. I had 0, but I need to put FF because default is pull up. Another error was that I had the size of this vector wrong. It was 8 instead of 9 bytes, which completely effed up my memory. So, but now it works. If I now push the keys on the first row and the number row, you will see them appearing in the brackets. Also, if I push the FN key now, we'll see we get 127, which is FN. Let's not worry about the null there. And if I now push the 1, 2, and so on keys again, you can see they're reading different values. In this case here, S and D, so 31, 32, 2, and 1. And if we look in the matrix, that's where the second matrix here has 31, that's where the first one has key 1. So if I pushed 1, it got 31. If I pushed key 2, it printed 32, so the key map switching works. Theoretically, I could implement even more modifier keys if I need to, but I think 2 key maps, so 1 FN key is enough. I don't want to waste another key on this already very scarcely laid out keyboard. I will have to invent some methods to get some of the keys working that are missing, but I think the FN key will get me covered for that. And just for anyone wondering where to get the key codes, those can be found in the HID usage tables for USB. That's, I think, what the Linux currently uses. And if you take a look at this document, then it'll look like that on page 53. Table 12 is one that's relevant for keyboards. And here the ref typical AT101 precision. That's the column we're interested in. For example, if we take a look here, keyboard 1 and exclamation mark are in position 2, and this position 2 is what I have here. So key 1 is key code 2. Okay, now to assigning proper key values, and I think then I can move on to the Linux driver part. No, I'm probably gonna continue with the printer because I have all the parts in by now, and then I will design the printer IC. And because the thing is, in my design, as you can kind of see in this drawing here, I will use two AVRs, one controlling the printer mostly. It will also talk to the Orange Pi using a secondary SPI bus, and it will talk to the keyboard controller over UART. That's how I'm probably going to design this. I originally wanted to use an ATmega32, but I don't think it has enough pins, so this is the next best solution. I don't want to go up to an ATmega 128 where I'd have to create my own PCB. Just too much work for like a one-shot thing like this where there's no reuse value for a PCB. Yeah, and here you can see that's the keyboard. So the thing is, it talks to this chip, so I need to implement this chip here before I can do the SPI, which means I should also have this chip before I implement a Linux driver for the keyboard, as we will have one Linux driver which does both the printer and the keyboard. Okay, thanks for watching, and we'll see you in the next episode in which I'll talk about the printer.